Picture this, a world without modern weather forecasting. People rely on folklore, on the skies, on stories passed through generations. And then, in the mid-15th century, the skies began to behave strangely. A great darkness spread across the skies, crops failed, winters were harsher. What caused it? Well, that's the mystery we're going to explore today. It's the story of a massive volcanic event that left few direct traces and still puzzles scientists. Imagine a time in the year 1452 or 1453, or possibly 1458, when thick clouds of volcanic ash drifted across continents and hemispheres. According to ice core data, scientists found a massive sulphate spike, evidence of a large eruption, yet no exact volcano has been definitively linked to the event. In parts of Asia, China's Ming Dynasty chronicles describe unusual winter conditions in 1453, snow where it seldom falls, failed wheat crops freezing, famine following cold, a strange portent of something beneath the earth. What makes the story compelling is the gap. We see the global climate anomaly, the sulfur spike, the weird weather, yet no clear this volcano erupted. Here's the crater, here's the record. One of the leading candidates is the submerged caldera of Kuwae Caldera in the Pacific, but even that has uncertain dating. Let's step back and trace the human impact. Picture an agrarian society in Europe or Asia relying on annual harvests. Then, out of the blue, or rather out of the ash-filled skies as the seasons shift, spring arrives late. The sunlight is weaker. Crops struggle, trade falters, famines mount, social unrest may follow. In short, the world changes, quietly but dramatically. Then imagine explorers, travelers, merchants in far-flung lands. They notice lower temperatures, odd sunrises, strange color in the sky, signs that something big has happened, beyond any one human life. What could possibly leave such a mark yet leave so little physical trace? Modern volcanologists, using ice core samples from Greenland and Antarctica, have isolated sulphate layers that correspond to enormous ejections of sulfur into the atmosphere. These events tend to cool the planet temporarily. One major eruption triggers a volcanic winter, but locating which volcano did this one, when exactly, remains unsolved. Let's walk through the clues. First, the ice cores. Researchers found a spike around 1452-53, and later redated more precisely to around 1458 for one of the events. Then, human records at the Ming Dynasty, European chronicles, reports of dim sun, cold years, crop failures. Then, the geological hunt. Where could the volcano be? Candidates include Kuwae, Tafua, others in the Pacific, but none match perfectly. Why does this matter for the people of that time? Because climate is everything. For peasants, for farmers, a shortened growing season means hunger. For rulers, famine means unrest. For traders, changing seas and winds disrupt shipping. A volcanic collapse can ripple outward socially. And yet, the people living it might simply write of bad winters or strange days. Now let's zoom in on one human narrative. Someone living in Europe, maybe a farmer in northern France, hearing tales from travelers of strange sunrises, of frozen blooms in spring, of famine in neighboring towns. They may not know the cause, but they live the effect. Meanwhile, across the sea in Asia, farmers in Ming China are writing in official records, spring frost destroyed wheat. Several feet of snow fell in provinces unaccustomed to it. The sky was dim. That's the thread of eyewitness record. And then there's the mystery of the missing crater. If a volcano erupted with a magnitude large enough to generate these sulfur spikes and climate anomalies, why don't we have a clear geological record? Part of the answer: it might be underwater, submerged, obscured by time, or simply misdated. The candidate Kuwae lies beneath the sea in Vanuatu. But even here the dating is debated. One of the great ironies: we have better global climate data from ice and tree rings than we do from contemporary human documents about the eruption itself. In other words, we see the echo of the event, but not the event clearly. That gives the mystery a haunting quality. The sky darkened, the world shifted, but the culprit remains hidden. Let's consider the scientific implications. When large volumes of volcanic ash and sulfur dioxide reach the stratosphere, they form aerosols which reflect sunlight. That leads to cooling. less sunlight, weaker summers. Historically, eruptions like 1815 eruption of Mount Tambora are well documented and their climate effects well understood, but in this 15th century case, the scale seems comparable, yet the source is elusive. From the vantage of today, the mystery reminds us how fragile the climate-human system is. One big geological event can ripple through seasons, economies, politics, and even transform the course of history. And yet, because it happened so long ago, its details are fuzzy. Which means we live with questions. Who experienced it? How did societies adapt? Did some regions fare better than others? What records remain in dust, in ice, in human memory? For your audience, imagine closing your eyes and picturing the sky growing dim in the afternoon, crops sagging, and distant rumors of a volcano in the sea rising above the horizon, raising columns of ash. Ships delayed, harvests lost, communities huddled in winter that felt endless. Then imagine centuries later scientists drilling deep into ice, pulling a tiny slice of history, discovering the sulfur signature, realizing something enormous once happened but the eyewitnesses are long gone, and the crater remains hidden beneath the waves. So what do we take away from this? First, history isn't only kings, wars, inventions, it's also climate, geology, the unseen forces shaping human life. Second, mysteries remain. We may never identify with absolute certainty exactly which volcano caused the event in the 1450s, but the investigation itself teaches us about resilience, adaptation, human records, and scientific detective work. Third, the story invites wonder. Why do we live in the age we do? How different might our world be if the skies had darkened further, crops had failed more widely? In a moment I'd like you to think, what would you do if faced with a strange winter you couldn't explain? How would communities respond without modern communication, scientific knowledge, or relief systems? This event invites us to imagine our ancestors' world. It invites us to ask, what vessel of record would you leave for the next centuries? What would future scholars drill into ice cores or read in your weather journals? Rounding off, though not ending, I'll leave you with one more image. Waves of ash drifting across oceans, the setting sun turning crimson, traders in medieval ports talking of fog that doesn't lift, farmers in China writing of wheat fields frozen under unusual snow, and millennia later scientists in labs in Antarctic and uncovering the sulfur spike, realizing something huge. And humanity, watching the sky, responding to the unknown.